Okay, hello everyone. In this video I decided to make one more technical calculation to show how the Shiab operator probably should work in geometric unity and how the Ricci expression should appear out of those equations which Eric writes in his draft. And then you'll see what the problem is more clearly. Okay. That's what we tried to do yesterday. So yeah, we'll be working with this equation. Okay, let me rewrite it in a slightly different form. I apply star on both sides. Well, up to plus minus sign, I don't care about it right now. We'll only look at proportionalities because that's enough for all purposes. So at first, yeah, he claims that this should become the cosmological constant. How exactly could it even work? We know that T omega looks like this. It's omega minus epsilon dA0 epsilon, something like this. Sorry, actually, this omega in his notation is this weird pi, but it's inconvenient for me to write it, so I will just denote it as omega everywhere. Yeah, and we know that this pi or omega takes values in one forms on y valued in the Lie algebra of the unitary automorphism of spinor bundle. So how in principle even this could work? He uses this identification, right, that omega complexified y of at which is omega 1 c y tensor the Lie algebra of automorphism, unitary automorphism of spinor bundle, like this, is isomorphic to tensor all exterior powers. As representations of spin group. Okay, and then inside of it we have omega 1 of y tensor omega 1 of y. And this gets reduced to after we use the pullback, omega 1 of x tensor omega 1 of x, and here we have symmetric part of it, so we should have some metric. Some metric would live there. That's probably the logic. So in coordinates, what does it mean? That we take this omega and we write an expansion like this. Omega is one form, right? So the zero term looks like this. Then we have the first degree term, gamma A. So gamma is like our gamma matrix, plus and so on, higher degree terms. AB, dx mu, tangent, gamma A, gamma B, and so on. So we need this part. We use this isomorphism, which is essentially given by, I guess, this Dirac representation, right? This rho of dx nu is e nu a gamma a, but this is our tetrad, something like this. And then we write omega mu a 1 dx mu gamma a as omega mu a 1 e a nu dx mu tensor dx mu, and this we call omega mu 1, and supposedly, I guess, it should reduce to a metric. Again, it's not even symmetric in mu nu, so we probably need to take symmetric part by hand. I don't know. It's not clear, and it's not clear why it has anything to do with the metric on x. I guess it's just you're doing it by definition. Now, for the hard part, this guy, as you remember, it has two terms. I think I will only do the calculation for one of the terms, and you could do another one yourself, because it's more complicated. Yes, so I will only do this term, epsilon inverse phi 1 epsilon star f. Which supposedly should give us the just call it Ricci like. We'll see what he means by it. So if I apply the first star, I will get something like this. Mu a epsilon f mu 0 mu 1. There is a metric, again a square root of metric, but I probably will not write it anymore. Mu 0 mu 1 and mu 2 and so on tells mu 13 dx mu wedge dx mu 1 dx mu 13. Okay, so because Shiab operator with in a curved space probably look like this, yeah. So okay. So now we need to expand our f mu 0 mu 1. It also will have potentially all sorts of terms, like it starts like this: f mu 0 mu 1 0, and then f mu 0 mu 1 1 a gamma a plus f mu 0 mu 1 2 ab gamma b plus and so on. But probably because it's spin connection curvature, by his construction, he probably only means it only has this second degree term, because it should supposed to take values in the Lie algebra of the spin group, which is degree 2 part of the Clifford algebra. That will make our life easier. Yeah, let me just, for simplicity, replace index here by C, so I don't have the same index twice. Now what also will help, if epsilon would also be taken value in the spin group. I don't know whether it's true in his notation. Then we would have a simple formula. This would act linearly, right? It will be some sort of formula like this. And this allows us to make some explicit calculations, because then we would have mu c epsilon inverse gamma c epsilon, commutator is f mu 0 mu 1, will give us this type of thing. Here I'm writing commutator because this is antisymmetric, right? So we can do it. Then gamma matrices behave like vectors under the action of the spin group, right? So we'll get something like this. See, again, I'll not care about the sign. Now, this is antisymmetric on A and B, so I could just simplify it a little bit. Okay. So that's the answer, and now we need to apply Hodge star again. So when you'll be applying Hodge star twice, we again need to use the relation. And be proportional with some coefficient to G mu 0 lambda, G mu 1 mu minus G mu 0 mu, G mu 1 lambda. So the answer which you'll get again, because mu 0 mu f is antisymmetric and mu 0 mu 1, these two terms will give me the same result. Let me call the coefficient, I don't know how you call it better. I already have A, so I don't know. We have all the letters L. I'll get 4 rho epsilon inverse CA epsilon mu C F mu 0 equals lambda mu A B gamma B. Okay. So now we see the interesting part. So indeed, what's happening here is that this thing, what it does, effectively it pairs the index A and mu, right? Contracts them. So that's Eric Weinstein's, I guess, what he called generalization of Einstein projection, right? Or P, E, or Einstein contraction. That the Ricci curvature is equal to projection of the Riemann curvature. And that's I guess what performs this contraction is now this kind of new entity, which depends on some dynamical variable epsilon. So this is not like actual real Ricci curvature, it's some sort of weird object like this. And which I guess supposed to at some point reduce to just usual four-dimensional metric. Oh yeah, I missed determinant of G. But it's unclear why, and we already have the role of the metric taken by omega 1, right? Symmetric part of it or something. So in what sense this thing and this thing reduce to the same objects, which should be just a metric in the four space, is unclear. Why it's supposed to happen, how this reduction works. This all should be explained in all the details. So far it's not done, at least not in the draft, and I could not guess it by my own without proper explanation. So that's it. I guess that's the end for today. Don't know whether you enjoyed the calculation. As an exercise, you could do the Ricci scalar part. I don't know, I haven't done myself. Was it any better or not? See you next time.